All right, this is the video for Unit 3, Lesson 2, Multiplying and Factoring Polynomials. So we're going to start off with multiplying. You should be somewhat familiar with problems that are set up like this, where you've got parentheses and then something outside of the parentheses. You are probably more familiar with when there are just numbers on the outside. And it should be a review of the distributive property. However, because this is an example of the distributive property with a variable, we have to use our exponent rules that we learned in the last unit. So I'm going to distribute that 2b to everything inside the parentheses. So I multiply 2b times b, and that gives me 2b squared, because I'm multiplying 2 times b times another b, 2b squared. And then I'm going to multiply the 2b times 11. Since there's no variable, I would just multiply the 11 and the 2, and I get plus 22b. Now, some of you may have the instinct to combine these terms and add the 2 and the 22. However, we will not be able to do that because we have a 2b squared and a 22b. So because those exponents are different, we have a b squared and just a regular b, which is the same thing as b to the first. Because those exponents are different, I cannot combine them. So this is my final answer, 2b squared plus 22b to the first. All right, moving on to the next example. Once again, I have something outside the parentheses, so I have to distribute it. So I'm going to distribute the minus w squared times the w and times the minus 15. So minus w squared times w, we have a negative times a positive term, so it's going to be minus, and I have w times itself twice with the w squared, multiply it by w one more time, and I get minus w to the third. And then when I multiply that minus w squared times minus 15, multiply two negatives, that gives me a positive, so I add 15w squared. Since there's no variable with the 15 and there's no coefficient with the w squared other than just that minus, I just multiply the 2, and this is my final answer. And once again, these are not like terms because they have different exponents, so I would leave that as my final answer. The next example is a monomial, this one term on the outside, times a trinomial with these three terms. But I'm going to distribute it the same way that I've done the other ones. Oops. So I'm going to multiply, oh, I lost my mouse now. There it is. Multiply negative 8y to the third times the 7y squared. Then I'm going to multiply that negative 8y to the third times the minus 4y. And then finally times the minus 1. So negative 8y to the third times 7y squared. I multiply the coefficients. Negative 8 times 7 is negative 56. Y to the third times y squared. I add the exponents. That's what we learned in our exponents unit. If I multiply two terms with the same base, then you add the exponents. And then I multiply times the middle term, which is minus 4y. Negative 8 times negative 4 gives me plus 32. Yep, 32y to the fourth, because I add one more to my exponent of 3, since I'm multiplying it by one more y. And then finally, if you multiply anything times negative 1, all it does is change the sign. So because it's a negative times a negative, I get plus 8y to the third. When I multiply negative 8y to the third times negative 1, that's what I get. And once again, all the exponents are different, so I can't combine any like terms here. So that one is done. All right, GCF. GCF stands for greatest common factor. So what you're trying to do is find the biggest thing that you can divide everything by evenly. So for example, if you have, let me think of a good one. If you have 8 and 12, you can divide both of those by 4 and get integers. So 8 divided by 4 gives you 2, 12 divided by 4 gives you 3. So 4 is the greatest common factor because there's nothing that I can divide 8 and 12 by evenly that's bigger than 4. So 4 would be the greatest common factor. So for polynomials, there's two parts of the greatest common factor. You want to look at the coefficients, and then you want to look at the variables. So for my coefficients, I want to look at 8 and 18. And I want to figure out what's the biggest number I can divide both of those by. And in this case, it is 2. Yes, because you can't divide 18 by 4. So 2 is the biggest number that I can factor out of the coefficients. Now I want to look at my variables, and I'm always limited by the variable with the lowest exponent. So between the w squared and the w, I can factor a w out of w. Anything is a factor of itself. And I can also factor one w out of w squared. So I can factor a w out of both of those. So my GCF is going to be 2w. For this next one, remember I always still want to look for my coefficients and my variables, but notice that this one has a term where the variable coefficient isn't written there. So a to the third is the same thing as 1 times a to the third. So because I have 1a to the third, that means that the biggest number that I can factor out of all of my coefficients is 1, because that's the only factor of 1. So the biggest number I can factor out of my coefficients is just 1. And then when I look at my variables, I have a to the third, a squared, and regular a. So once again, I'm limited by my lowest exponent, which is just that a. So this is just 1a is the biggest thing that I can factor out. That's my GCF. This next one, let's see. So our coefficients are 14 minus 42 and plus 21. So if I look at all of those, I can divide all of those by 7. So that's going to be my GCF for the coefficients. When I look at my variables, I have z to the fourth, z to the third, and z squared. Once again, I'm limited by my lowest exponent, which in this case is z squared. So you might be wondering like why I can factor, like I can't divide 3 by 2, so why can I factor z squared out of that middle term? Makes a little bit more sense for the first term, but what about that middle term? So remember that z to the fourth is z times z times z times z. Z to the third is z times itself 3 times. Z squared is z times itself 2 times. So if I want to take out the greatest common factor, or if I just want to figure out what the greatest common factor is, so 2 is the smallest amount of z's that I'm multiplying together. And then for each of these, I can just put some parentheses around 2 z's. And you can see that, you know, I'm just multiplying those 2 z's times something else. So you can easily see that z squared is a factor of all 3. So hopefully that visualization helps a little bit. But again, you are limited by the smallest exponent, so it would be the z squared. And so our greatest common factor would be 7 times z squared. Moving on to some factoring. So once we know what the greatest common factor is, how does that help us? Well, let's look at this one. So if I look at my coefficients, I've got a 5, I've got a 20, and I've got a minus 15. So all of those, the greatest common factor is 5. So I know my GCF is going to include a 5. Now notice that this minus 15 doesn't have a variable at all. So I can't factor out any variable terms from all 3 of these terms in the polynomial because that minus 15 doesn't have a k, so I can't factor even 1k out of all 3 of the terms. So my greatest common factor for this one is just 5. I can't do anything else. I can only factor out of 5. So then with factoring, you have to figure out what is left over. So essentially, I'm dividing each of these three terms by 5. So if I have 5k to the third divided by 5, well, the 5's cancel and I'm just left with k to the third. If I divide 20k squared by 5, factor a 5 out of both, and then I'm left with plus 4k squared. Notice that all my k terms are staying the same because I'm not factoring any k's out. And then finally, minus 15 divided by 5 gives me minus 3. So in factored form, this becomes 5 times, parentheses, k to the third plus 4k squared minus 3 end parentheses. And that's it. That would be the factored version. This next example, we have 14x to the third minus 2x squared plus 8x. So to find my greatest common factor, I'm going to look at my coefficients once again. So I've got a 14, I've got a minus 2, and I've got an 8. So a good rule of thumb is to always look at like the smallest number. Well, not always the smallest number, but the number with the smallest amount of factors. So like for example, 14, I could divide that by 2 or 7 or 14 or 1. 8, I can divide that by 2, 4, yeah, those, and then 1 and 8. But this minus 2, I can only divide that by 1 or 2. Like those are the only factors. So you definitely want to be looking for the 2, because if it's 1, then you're not really factoring anything out. So the 2 is a good place to start because it kind of limits what you're looking for in the other numbers. So my greatest common factor for this one is going to be 2 because I can divide all 3 of those green coefficients by 2. And then when I look at my variable terms, I have an x to the third, I have an x squared, and I have an x. So my smallest exponent is this x to the first power at the end. X or x to the first power, they mean the same thing. So I can factor 1x out of each of those terms because they all have at least 1x. So now I'm going to divide each of those terms by 2x. So 14x to the third divided by 2x. Factor out a 2, factor out an x, and you're left with 7x squared. And then the next one, minus 2x squared over 2x. Factor out a 2, and you're still left with the negative, because remember you're dividing negative 2 by positive 2, so you've got negative. And then x squared divided by x just gives you regular x. And then finally, if you have 8x divided by 2x, the x's cancel, and you're just left with plus 4. So if you, another way to do this is to just divide the coefficient by what you're factoring out. So like divide 8 by 2 and you get 4, and then divide x by x and you get 1. So you're just left with 4 there. So hopefully these examples helped you out. If you have any questions, please feel free to reach out to your teacher. And good luck with the rest of your lesson.